So homework day 40, the end of the pie chart. These are the last few things on your pie chart, and you should be able to finish your pie chart. Starts with the Pythagorean theorem. So, many years ago, before TVs, computers, and all the fun things we have, there was a guy named Pythagoras. He figured out that if you have a right triangle, that the sum of the legs squared is equal to the hypotenuse squared. Well, what in the heck does all of that mean? The legs of the right triangle are your two short sides. I'm going to label them A and B. The hypotenuse is the side that is opposite the right angle. That's your long side. Right? That would always have to be longer than the other two sides if it's opposite that right angle. So Pythagoras came up with the Pythagorean theorem that says if you do a squared plus b squared, it's equal to c squared. The sum of the legs, the two short sides squared, is equal to the hypotenuse squared, the longest side squared. So on this problem, you want to make sure you pick out which one is the hypotenuse, because that's the one that's going to be by itself after the equal side. So here would be my two legs. Here's my hypotenuse. 9 squared plus 11 squared is going to equal x squared. I've got it all set up. Now again, Alex probably solves this in a little bit different order than I do, but I like to get rid of my squaring first. So 9 squared, 9 times 9, 81. 11 squared, 11 times 11, 121. 11 squared plus 100, or 9 squared plus 11 squared, 81 plus 121 is equal to x squared. So I'm going to add those. 81 plus 121 is equal to 202. Well, that's equal to x squared, not just a plain x. So, when I solve this, it was a really long time ago that we had some with x squareds in, but when I solve it, I have to do the opposite of squaring. So to get rid of that squaring, what I'm going to do is do the square root of both sides. The square root of an x squared is just a plain x. On this one, I'm going to use my calculator because I'm going to round to the nearest hundredth. So I'm going to grab my calculator. The square root button is right next to the fraction button. I'm going to do the square root of 202, and I'm going to hit equals. I get 14.2126, so forth and so on. I want to round to the nearest hundredth. 2 places after my decimal, since there's a 2 behind it, I'm just going to leave that as 14.21. Now my hypotenuse should be the longest side. It is longer than the 9 and the 11, so that looks like a good answer. 14.21. Number 2, we are still doing the Pythagorean theorem because we have a right triangle. Again, when you're thinking about the Pythagorean theorem, you're saying a squared plus b squared equals c squared, and that's always the long side, the hypotenuse. Well, which one is my hypotenuse? In this case, the 11 is my longest side. So when I set up my Pythagorean theorem, I'm going to say 10 squared plus x squared equals 11 squared. The 10 and the x, if you switch them around, it's fine. You're going to get the same thing because they're on the same side. But the 11 has to be on that other side. So 10 squared is 100 plus x squared equals 11 squared, 121. Now in this one, to solve it for x, I've got to move my 100 over with my other number because I've got to get the x by itself. So I'm going to minus 100. X squared is going to equal 21. I then have to solve that by getting rid of the squared, so I take the square root of both sides. The square root of x squared is just x. I'm going to do the square root of 21 on my calculator, 4.582, and so rounding that off to the nearest hundredth, x is going to be 4.58. Right, that should be shorter than my hypotenuse, so that looks like a good answer. The third one, using my Pythagorean theorem. Now they got my triangle turned all topsy-turvy, but if I look, here's my right angle, so my hypotenuse is the 13. Setting up my Pythagorean theorem then, x squared plus 10 squared equals 13 squared. So getting rid of my squaring, x squared plus 10 squared, 100, equals 13 squared. 13 squared, 169. Again, on this one, I want to get the x squared by itself, so I've got to move my 100 to the other side. X squared equals 69. And now I want to get the x by itself, get that squaring out of there. The opposite of squaring, taking the square root. So on my calculator, the square root of 69 gives me 8.3066. I want to round to the nearest hundredth. Since there's a 6 behind there, I got to round that up to 8.31 then. And again, that's one of my legs, so it should be shorter than my hypotenuse. It is. So it looks like a good answer. So key to the Pythagorean theorem is that the hypotenuse, the long side, is the one always over here by itself. The sum of the legs squared is equal to the hypotenuse squared.